Imagine standing on a beach, but not today's beach. The ocean stretches far beyond what you know. The air is thick and heavy. You hear the crash of waves hundreds of kilometers inland, where once there were cities, forests, and farmlands. The Earth has heated by just 5 degrees Celsius. The same rise scientists warn could happen again. But this isn't a glimpse of the future. This already happened once before. And when it did, it changed everything. So what did the world look like the last time Earth heated by 5 degrees? And what can it tell us about where we might be heading? Picture Earth 55 million years ago. Long before humans, long before ice sheets, long before the world had any idea what cold really meant. The planet was already warm, lush, and humid, a paradise of green stretching from pole to pole. But then something happened. Something that would turn that paradise into a furnace. Deep beneath the ocean floor, trapped carbon began to release, perhaps from volcanic eruptions, methane hydrates, or massive wildfires triggered by tectonic upheaval. The reason is still debated, but the effect was undeniable. In just a few thousand years, Earth's temperature rose by about 5 degrees. The oceans darkened. Coral reefs bleached and died. The Arctic, once mild and forested, turned into a steaming swamp filled with crocodiles and giant ferns. Rainforests expanded northward, while deserts crept into once fertile lands. The air grew heavy with carbon, about as much as modern humans have released since the Industrial Revolution. But the ancient Earth did it 10 times slower. And even at that slower pace, the results were devastating. The sea levels rose more than 70 meters. Entire coastlines disappeared. Temperatures at the poles rivaled today's tropics. It wasn't just a heat wave, it was a planetary fever. The Paleocene-Eocene Thermal Maximum, the PETM, marked one of the most violent transformations in Earth's history. And yet the world didn't die, it changed. Life adapted, painfully, slowly, and sometimes beautifully. But the cost was enormous. If you could breathe the air of that time, it would feel thick, heavy, and strange. The concentration of CO2 had doubled, maybe tripled, compared to what we breathe today. Oceans absorbed much of that carbon, but it came with a price: acidification. Shell-forming creatures like plankton and mollusks found it harder to survive as the water grew more corrosive. The base of the food chain began to crumble. As carbon levels rose, the planet's balance shifted. The tropical belt expanded, bringing monsoon-like rains and intense storms. Forests near the equator became stifling hot, forcing species to migrate north and south. Animals, unable to adapt fast enough, started dying in massive numbers. Geologists studying ancient sediments today can still see the scars. A thin, dark layer rich in carbon and fossils of species that didn't make it. It's the fingerprint of the PETM preserved in stone, and here's what makes it chilling. The total amount of carbon released then, roughly 4,000 to 6,000 gigatons, is similar to the amount we could release this century if emissions continue unchecked. But there's a catch. What took ancient Earth 20,000 years to unfold, we're doing in just 200. In geological terms, it's like watching a glacier melt and fast forward. Eventually, Earth fought back. Over tens of thousands of years, silicate rocks began absorbing CO2 through weathering, locking carbon away in sediments. The ocean slowly cooled. Life began to recover, though it would never be the same again. New species emerged to fill the gaps. Primitive horses, early primates, and strange mammals appeared, adapted to the heat. Evolution accelerated. The survivors weren't the biggest or strongest. They were the most flexible. By the time the planet cooled back to normal, entire ecosystems had evolved into something new. But the PETM left behind a warning written in the very rocks. Even a small temperature rise can completely rearrange life on Earth. What's most haunting is how familiar this all sounds. Back then, carbon escaped from the deep ocean and volcanoes. Today, it comes from factories, cars, and power plants. Different cause, same effect. And as scientists study that ancient meltdown, they see our future written in its ashes. The question is, will we learn from it before history repeats itself? As Earth's fever burned on, the rules of survival changed overnight. Forests that once offered cool shade turned into steaming jungles. Grassy plains dried into scrublands. For countless species, migration became the only way out. Across continents, animals began moving toward the poles, chasing cooler climates. Fossil records show entire ecosystems on the move. Tropical trees appearing in what is now Wyoming, and crocodiles swimming through what would one day become the Arctic Circle. Early mammals, small, shrew-like creatures, scurried north, adapting their diets and behaviors as they went. They were quick, clever, and curious, the very traits that would one day give rise to primates like us. But many others couldn't keep up. The heat pushed them beyond their limits. Large-bodied species struggled to shed heat, and the changing vegetation starved herbivores who couldn't find the plants they once relied on. In the oceans, migration patterns shifted too. Plankton, the foundation of the marine food web, began dying in warmer, more acidic waters. Fish followed cooler currents, driving predators and prey into unfamiliar waters. Every living thing, from the smallest microorganism to the largest land mammal, was caught in a global game of survival. It was evolution in motion, fast, chaotic, and merciless. And out of that chaos, the story of modern life began to take shape. The heat didn't just move animals, it transformed their homes. Rainforests became denser, filled with towering trees, tangled vines, and an explosion of insects. But what looked like abundance was also instability. Plants grew faster in the heat, but struggled to reproduce as rainfall patterns changed. Many species of trees disappeared altogether, replaced by others better suited to drought and heat. In these shifting forests, the ancestors of today's primates made their debut. Tiny, tree-dwelling mammals with grasping hands and forward-facing eyes learned to navigate a world of branches and shadows. The PETM, as catastrophic as it was, became a crucible for evolution. Without it, primates, and eventually humans, might never have emerged. But for every species that thrived, dozens more fell. Insects invaded new areas, spreading diseases to plants and animals unprepared for them. Some ecosystems collapsed entirely, their balance broken beyond repair. And deep in the soil, the carbon cycle churned on, a reminder that the very forests that grew so wildly were also releasing and absorbing carbon in a delicate dance that shaped the planet's climate. Earth, it seemed, was experimenting, testing what life could endure. For many creatures, the PETM was the end of the road. Roughly 1/3 of marine species vanished, including numerous foraminifera, tiny organisms that recorded the world's chemistry in their shells. On land, countless plants and animals disappeared, their fossils abruptly ending in that dark, carbon-rich layer that marks the PETM across the globe. But extinction, cruel as it is, often clears the path for something new. As ancient species died off, new mammals rose. Small-bodied, warm-blooded, and adaptive, they thrived in the heat. Early hoofed animals diversified. Tiny primates expanded across continents. Evolution seemed to favor intelligence, speed, and flexibility. In a way, this chaos was nature's reset button, a brutal but effective way of reshaping life for a warmer world. And it worked. Within a few million years, ecosystems stabilized, greener and stranger than before. The survivors of this age became the ancestors of the creatures we know today, including, eventually, us. Yet their success carried a warning. Survival didn't mean invulnerability. It meant adaptation, constant change, endless struggle. Because even though Earth cooled again, the scars of that great heating event never truly faded. And millions of years later, when another 5-degree sea rise began, this time powered by humans, those same evolutionary lessons returned to haunt us. Far beneath the ocean floor, buried under layers of sediment, scientists have found something extraordinary. A thin, dark line of clay. To the untrained eye, it's nothing, but to geologists, that layer is a time capsule from 55 million years ago. It marks the exact moment Earth last heated by 5 degrees. Within that layer lie the fossils of species that vanished and the chemical fingerprints of a planet in turmoil. It's called the Paleocene Eocene Thermal Maximum, or PETM, and studying it has become one of the most urgent, scientific quests of our time, when researchers compare those ancient signals to the data we collect today, from carbon dioxide levels to ocean acidity, they see something unsettling. The numbers match, almost perfectly. It's as if the planet is replaying an old nightmare, only this time the tape is sped up 100-fold. The ancient event took tens of thousands of years to unfold. We've managed to trigger similar changes in less than 2 centuries. The last time this happened, it took Earth 200,000 years to recover. So what happens now? When the same forces are unleashed, but faster, hotter, and with nearly 8 billion humans in the mix? The answer may already be unfolding around us. Every climate system has a breaking point, a threshold beyond which the planet's feedback loops spiral out of control. Scientists call them tipping points, and the PETM showed us what happens when they're crossed. Back then, warming melted permafrost and released even more methane, one of the most potent greenhouse gases, into the atmosphere. The result was runaway warming. Today, we're seeing similar risks. Melting ice in the Arctic could release billions of tons of trapped methane. Amazon rainforests, once carbon sinks, are now starting to emit more CO2 than they absorb. Coral reefs, Earth's underwater rainforests, are bleaching faster than they can recover. And while the PETM unfolded slowly enough for some species to adapt, our modern crisis moves at breakneck speed. We're adding carbon to the air 10 times faster than nature did back then. Evolution can't keep up. Ecosystems can't adjust. Even the ocean, which once buffered Earth's heat, is beginning to fail under the strain. If the PETM was a warning, this is the alarm bell. A 5°C rise isn't just warmer weather. It's an entirely different planet. One where coastlines drown, crops collapse, and billions of lives, human and otherwise, are forced to move or vanish. The story of the PETM isn't just ancient history. It's a mirror. It shows how easily Earth's balance can be tipped and how long it takes to heal. It reminds us that the planet will survive, but survival for us is another matter entirely. When you look at the data, the carbon, the heat, the extinctions, it's like reading a script that's already been written. The only difference now is that we hold the pen. For the first time in history, one species has the power to decide how the next chapter ends. But that power cuts both ways. The same intelligence that unleashed this warming can also stop it. Renewable energy, reforestation, and innovation aren't just buzzwords. They're tools to rewrite what could otherwise become another PTM. Because make no mistake, the last time Earth heated by 5 degrees, the world that emerged was alien compared to the one that came before. And if we let it happen again, we won't be the same species when it's over. So perhaps the better question isn't what happened last time Earth heated by 5 degrees. It's what will we do differently this time? The last time the Earth warmed by 5 degrees, it took 200,000 years to recover. This time we don't have that long. But awareness is a form of action. Every conversation, every choice, every innovation is a small reversal of that ancient pattern. Because the planet doesn't need saving, we do. If you found this story haunting, eye-opening, or strangely familiar, consider joining the journey. Subscribe for more deep dives into our planet's forgotten past and the future it still warns us about.